Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, it's me, Mostafa Shaikhoun, and this is ELV Systems Fundamentals course. In the previous videos, we talked about principles of electricity. Now we know the law of power. We know what does mean wattage, what does mean voltage, what does mean current, what does mean amperage. And now we know how to scale or calculate our loads. It's very important to know how to calculate your loads before you study solar energy system or PV systems, because you should be able to estimate the loads, the power that you need, and depend on that you have to design solar energy system to power on your systems. I gave some examples before. I told you, for example, someone asked you to install a CCTV camera in somewhere, has no electricity, has no services, and he asked you to power on this system. So no chance to call the municipality or to ask the service from municipality. It's no chance to get Etisalat services. You have one option that to power on your system, that is solar energy system. So the only solution is you have to know how to build or implement solar energy system for this farm to feed and power on the CCTV system. And you cannot do that if you don't know how to estimate and calculate your power. So today we're gonna start from scratch, study the solar energy system. Actually, in solar energy field, we have more than one system or one type. I'm gonna mention the solar systems type, and we're gonna check which one we're gonna study in the course. First one here is off-grid system. Some people call it standalone system. This system consists of solar panels, charge controller, battery. Sometimes we put inverters, and it's working alone without connecting to the grid. Another system is on-grid system. It operates entirely on the grid without needing batteries. It consists of solar panels, charge controllers or inverters, and there is no any battery. The last one is the hybrid system. It consists of solar panels, inverter or charge controller, and batteries. And also we can connect to the grid. So we have two types. We can connect to the electrical grid, and these systems are on-grid system and hybrid system. But off-grid system or standalone system, we cannot connect it to the electrical grid. And that's what we're gonna study today in our course, and that's what gonna help us in under construction site. Let's gonna know what is the components of solar power system. The first component is the solar panel. That component is primary if you're gonna install off-grid system, on-grid system, or hybrid. The solar panel we use to convert the sunlight into direct current, DC electric, or we use the sunlight to convert it to power. That power we're gonna store in the batteries to use it later. We have two types of solar panels. The first one is monocrystalline. The monocrystalline is higher efficiency and higher price. And that one, as you see here, is the mono. You can differentiate the shape between mono and poly like this. Here we have some curves in the square, but here straight square. And here it's dark, the color is darker than poly. And the polycrystalline is lower price and lower efficiency. That doesn't mean that the poly is not good. So it's good, it's working. But if you need the higher performance, you have to go to monocrystalline. If you have budget, you have to go to monocrystalline. But your budget is less and the project is not big, so polycrystalline is enough. The second component is charger controller. We use that charger controller to regulate the voltage and the current that coming or comes from the panels to the batteries. And also it protects the batteries from overcharging or over discharging. We have two types of that device. We have one called PWM, abbreviation or shortcut for place width modulation. That one is cheaper price and also it has loss. That one we use it in small project that has low power consumption. Another one is MPPT, shortcut for maximum power point tracking. This one is higher efficiency. We use it in medium and big projects and it maintains the current. It has less loss. Also doesn't mean that PWM is not good. As I told you in the solar panels, if your project is small and your budget is not too much, so PWM is gonna be enough for you. Here that picture displays the controller closer. As we see here, display screen to show you the voltage comes from the panel, shows you the battery status, and here we have two ports. Sometimes we have, sometimes we don't have, but that type has two ports, USB to charge your mobile, or you connect any load works with USB. Here as you see where you connect the solar panels, the positive and negative, and here it shows you where you connect the batteries, and here it shows you where you connect the loads. Don't never ever connect the controller with solars first. First step you do when you make installation is to connect the solar charger with the batteries. After that you can connect the solar panels. And that one outputs 12 volt, 24 volt, 48 volt. And you can connect directly the loads that works with the same voltage. Another component of the system is the batteries. The batteries, simply we use it to store electricity for use. The electricity or the power came from the solar panel and it passed through the solar charger to the batteries. Everybody know that. What is the function of the battery? To store the power, to use it later. We have lead acid batteries, we have gel batteries, and we have lithium batteries. And the lithium batteries is the most expensive battery and long life and more efficiency. Here we have another component sometimes we use, sometimes we don't need. It's not primary in the system. That's called inverter. We use this inverter to convert the direct current to alternative current. Means to convert from 12 volt DC to 220 AC. Why do we need to do that? Because sometimes we have some loads needs to feed or powered on with 220 volts. Here we have closer view from the back. We have positive and negative ports. We connect that one to the battery direct, and here we have sockets for output. It gives us 220, and here it takes 12 volt and convert it or amplify it to be 220 volt. We can use it with the loads or powered with high voltage. The cables are used in the system called DC cable. We cannot use any cable because there is special cables for solar power systems. It's a two core, as you see. We use it to connect between the solar panel to charge controller, and from charger controller to batteries, and from the batteries to inverter. The conductor usually copper or aluminum, nothing else, with strong and weatherproof insulation or jacket. Here we have the connectors that we use in the system. It's a special connector called MC connector. As you see here, it's waterproof and it's male and female. So one for the positive end, one for the negative end. We connect this metal to the wires and we try to push it in the connector. Once you push it in, you cannot take it out again, because we cannot make traditional joint, as we know. So in the solar power we don't do any traditional joint. We use MC4 connectors. Also we have here one device, I see it's important in the circuit, that called circuit breaker. The same one we use it in our homes. The function of that device is to disconnect the electrical current from electrical devices in case of fault or in case of short circuit. Before you buy that breaker, you have to calculate the power to get the suitable breaker for your system. So how we describe the cable cross section and the breaker for our circuit or for our system? We have one traditional rule says if I have a cable 1 millimeter, I can carry safely approximately 5 amps for 50 meters. For example, if I have 5 amps load, I can describe 1 millimeter cable up to 50 meter long. If I have 10 amps load, I can describe 2 millimeter cables. If my load is 20 amps, I can describe 4 mm cable for 50 meter long. If the load is 30 amps, I can describe 6 millimeter cable for 50 meter long. So that was for up to 50 meter. What if the distance more than 50 meters? If the length more than 50 meters, you should multiply by 1 for every 50 meters. For example, if the distance is 200 meters, 200 meters means 4 times 50 meters, right? So you should multiply the 6 mm by 4. It's gonna be equal 24 mm cable. That's gonna be safely how you carry 30 amps over distance of 200 meters. One more example, if I need to carry 10 amps load for a distance 100 meter, I'm gonna multiply 2 mm cable by 2, so it's gonna be 4 mm cable gonna be suitable to carry 10 amps for 100 meter. Here we're gonna describe the breaker, and we have one table here. You can take a screenshot to make it easy to calculate the cross section what you need for the cable, and you can describe the breaker that you need or the suitable one for you. I have one rule here says the breaker should be slightly larger than the load and the smaller than the cable rating. What does mean that? If you have an 18 amps load and the cable cross section is 4 mm, that can approximately handle 20 to 25 amps. So you have to choose 20 amps breaker. Also, you can use this table. It's a very nice table. You can take screenshot and keep it in your phone. Here, the cable cross section area. The cable that 1.5 mm can handle from 7.9 to 15.9 amps. That is approximately not accurate, but it's safely. You're gonna be in safe if you follow this calculation. And the recommended circuit breaker is 8 amps. Another one, if you have 2.5 mm cable cross section, that one can handle 15.9 to 22 amps, and we can describe 15 amps circuit breaker. Here we're gonna see how we fix our panels. We use something called panels structure. That structure are made of galvanized steel or aluminum. We have many types of that structure. We have the ground panels used for mounting panels on the ground, and we have the surface one. We use it to mounting panels on building roofs. Inclined panels also are used for the roof, but the sloping roof. And also, if we wanna track the sun, we have one type of structure called follower panels that used to track the sun movement for maximum productivity. So we knew the components of solar power systems. Now it's time to know how to calculate the loads. How we calculate the daily consumption of the devices? By multiply the device power by number of operating hours. As we see here in this table, we have LED lighting. We have 10 pieces, and the device capacity is 5 watt, and we're gonna operate that device for 8 hours. So 10 by 5, 50, and 50 by 8, 400. So the daily consumption only for LED lighting is 400 watt hour per day. Another load is the TV. We have one only TV. The TV capacity is 30 watt, and we're gonna operate that TV for 6 hours. So 1 multiply 30 equal 30. 30 multiply 6 equal 180 watt hour per day. We have one more load that called fan. The fan, we have one piece only, and the fan is operates with 50 watt. We're gonna operate that fan for 6 hours per day. So 1 multiply 50 equal 50. 50 multiply 6 equal 300 watt hour per day. So the fan gonna consume per day 300 watt hour per day. So the total wattage of the devices is 85 watt, and we need 880 watt hour per day to power on these devices. So while we are describing the system, we have to make sure that system gonna power on this calculation. So we need system to calculate, we need system to operate, or we provide us with 880 watt hour per day. Let me tell you, if you follow that calculation, you are wrong, because you calculate it exactly and you forget that we told you in the electrical systems we have drop voltage, we have lose. So what we have to do is to add from 20 to 30% to your daily energy consumption to be in the safe side from the losing. So we have here 880 watt hour per day multiply 1.3, or some people make it 1.2, gonna equal 1145 watt hour per day. So while I am describing the components of the system, I have to make sure that component gonna provide me with 1140 watt hour per day. Now we have to specify the voltage of the system you will be working with. The battery system voltage, which is 12, 24 or 48 volt. Here in that table we have one rule says if your load is less than 1200 watt, so you have to specify that you're gonna use 12 volt system. If your load from 1200 to 2400 watt, so you have to choose 24 volt system. If your load is 2400 to 4800 watt, you have to choose 48 volt. So here my load is 1145 watt hour per day. I'm gonna work on 12 volt system. So while I am making order for the batteries should be 12 volt. The charger controller also should be 12 volt. So to know how many ampere you need per day, you have to divide the result by the voltage. Our calculation here was 1145, and we says we're gonna use 12 volt system, so 1144 watt hour per day divided 12 volt, it's gonna equal 95.3 ampere hour per day. So I need every day 95.3 ampere hour. And also be considered that sun status. The sun not rising every day, or what I mean is it's not hot every day, not hot enough every day. So you have to determine how many days the sun might be absent or not hot enough, then you can get batteries to cover that period. And we say that before, the batteries we use it to store the electricity that comes from the solar panel. So here I'm gonna say that 95.3 amps that I got from the previous slide per day by 2. 2 here means 2 days. To keep in safe side for 2 days. So I need to cover or keep 190.6 ampere hour per day. Because I follow that calculation, and I have one day in the winter season there is no hot sun, my system shut down. The battery lifetime is depend on charging cycles. When you go to buy a battery, the seller telling you that this battery 3000 charging cycle or 1000 charging cycle. So to keep the battery working well for long life, you don't have to discharging the battery 100%. Here I'm gonna show you how to discharge the battery 50% to keep it working for long life. To make the battery discharging for 50%, we're gonna take the calculation, the result we got from the previous calculation, and divide by 0.50. So you're gonna equal that you need to cover 381.2 ampere. If you're gonna discharge the battery 80%, and that is recommended, so we're gonna divide it 190.6 ampere hour by 0.80. So you're gonna equal 238.25 amps. So you have to buy 4 batteries, each 100 amps, if you're gonna discharging the battery 50%, because here you need to back up 381.2 amps. If you need to back up 238 amps, you have to buy 3 batteries, each battery 100 amps approximately, and that is recommended. Why recommended? Because 80% discharging not bad percentage, and it's gonna be less cost. So now you know how to calculate the numbers of batteries that you need to back up the system. Let's calculate the panels. Let's describe the panels. What does mean peak sun hours? Peak sun hours means the most powerful hours from the sun, or the most high temperature from the sun. There is one map here shows you peak sun hours in all the world, and you have to find your country to determine the peak sun hours. In our country here, or in the Gulf area, the peak sun hours equal 5 hours, from 5 to 6 hours maximum. From the last slides we have one total here. The total watt hour per day we need to provide was 1140 watt hour per day. We divide by 5 hours, it's gonna give us 228.8 watt, and this is the required power for the panels. When we go to buy the panels, we have to buy panels provide us 228.8 watt. So we're gonna take this result and divide by 100 watt. We're gonna buy from the seller solar panels, each 100 watt, as we see here. So it's gonna equal 2.2 watt. That means approximately 3 panels, each 100 watt. So we're gonna buy 3 panels, each 100 watt, to provide me 228.8 watt. Let's see how we describe the charger controller. Here in the back of the solar panel, as we see here, there is one label or one sticker. The sticker has the solar panel specification. We should go to the short circuit current. We said before that we're gonna buy solar panels each 100 watt. So this is solar panel 100 watt. The short circuit current is 6.10 amps. We're gonna multiply this 6.10 amps by 1.3. It's gonna equal 23.79 amps. That means the charger should be 30 amps, 12 volt approximately. Here 6.10 amps. This is the short circuit current. By 3 means 3 panels. We're gonna connect to the charger controller. By 1.3 safety factor, as I told you, it's a spare. So 23.97 amps. I think there is no in the market 23.79. I think there is 30 amps. So we're gonna ask, or we're gonna order 30 amps at 12 volts. Let's calculate the inverter, or let's describe the inverter. How we describe the inverter? The inverter is the total consumption by 1.5. Let's see here what was the total consumption. Here the total capacity or the total of wattage of the devices was 85 watt. So 85 watt hour by 1.5 equal 127.5 watt. So we have to buy inverter that greater than 127.5 watts. And here I prepare one table to keep it in your phone. You can take screenshot of this table to keep it in your phone to make it easy to calculate. The total electrical loads was 880 watt hour per day. We multiply by 1.3 as a safety factor to keep myself safe from the losing. Equal 1145 watt hour per day. Next step is to determine the system voltage, 12 volt or 24 volt or 80 or 48 volt. So we take 1145 watt hour per day, we divide it by 12 volts, because we said if the load less than 1200 is gonna be suitable to use 12 volt system. So here my load is 1145 watt hour per day divided by 12 volt equal 59.3 ampere hour day at 12 volts. And we're gonna determine the system reserve. We said this 95.3 ampere hour day multiply 2, and that 2 means I'm gonna keep backup for 2 days equal 190.6 ampere hour. Next step is how to calculate the battery discharging to keep the battery life long life. We take this 190.6 ampere hour divided by the percentage of discharging, and we said we're gonna discharge the battery 80% equal 238.25 hours. 238.25 ampere hours. Let's calculate the numbers of the battery that I need to store the power or the backup. Here we're gonna divide 238.25 by 100 ampere hour. 100 ampere hours is the battery. The battery I'm gonna buy is gonna be 100 ampere hour 12 volt. You're gonna tell the seller I need battery 12 volt 100 ampere. So it's gonna equal 2.3 ampere hour. That means 3 battery, each battery 100 ampere. And how to calculate the numbers of panels that you need? We're gonna take the load 1145 watt hour day. That is the load after we multiply by 1.3 safety factor, and we're gonna divide it by 5 hours. 5 hours, that is the peak hours, the most powerful sunlight. It's gonna equal 228.8 watt. That is required power for the panels. So 228.8 watt divided by 100 watt, and we said we're gonna order solar panel each one 100 watt, so equal 2.288 watt. That means approximately you need 3 panels, each panel 100 watt. And the charger controller, we're gonna multiply the short circuit current here in the back of the panels by 3. 3 means 3 panels by 1.3 safety factor equal 23.79 79 amps. We don't have 23.79 amps charger controller in the market. That means the charger controller approximately should be 30 amps or higher than. And to calculate the inverter, you need multiply the load by 1.5. The load here was 85 watt. So that 85 watt multiply 1.5 safety factor equal 127 watt. So you have to buy inverter greater than 127.5 watt. And here how connect or how we wiring the system. We have two types of connection. We have series connection and we have parallel connection. In the series connection, we connect the positive terminal to the negative terminal. For example, the positive of this panel to the negative of this panel, and that's gonna make added for the voltage, and the current will be remain. Parallel connection, we connect the positive terminal to the positive terminal, means we connect the positive to positive as we see here, and the negative to negative. Also in the battery, the positive to positive, negative to negative. And don't miss the polarity. Don't never ever miss the polarity. The result in parallel connection is the voltage remains constant and the current is added. As we see here, we used the parallel connection. We connect the positive from the panel to another panel, to positive another panel, and the negative of the panel to negative another panel, and then it's going directly to the charge controller, also in the positive to the positive, negative to the negative. Then the batteries, the positive was positive, negative was negative, and going directly to the charger controller. And we said don't never ever connect the panels to the charger controller first. You should connect the batteries to the charger controller first. Then the inverter, it's connected directly to the batteries to convert from DC to AC. Here's some of our works. For example, you have under construction site, and the site engineer asks you to install camera, and he said, I am not gonna provide you electricity, I'm not gonna provide you اتصالات service. So we bring here one solar panel and one charger. As you see, let's make zoom here. So that system consists of solar panel, solar charger controller, the battery, the loads, and the waterproof box that I'm gonna store the battery charger and the 4G router inside. And this is the result. The solar panel to convert the sunlight to power, and there is inside one battery to store the power, and there is one charger controller to control the voltage comes from the panel to the battery. And we have here 4G router working with SIM card to make the camera online. And also, of course, we have the load. The load here is a camera and the 4G router. This is from inside the waterproof box. There is charger controller, there is a battery, and also I'm gonna connect the 4G router here. This is what we call it off-grid system or standalone system. Steps for implementing an off-grid solar energy project. We should study the electrical requirements. After that, calculate the daily electrical load required for your devices in watt. Determine the operating hours per day for each device. Determine the solar panel capacity. Determine the battery size. You should select a charger controller suitable for your system. Select an inverter, of course, suitable as per the calculation. Choose a suitable location for mounting the panels, rooftop or structure. In the big project, you should consider the direction of the panels. Q and A. What is the difference between off-grid system and on-grid system? The answer is off-grid system operates completely independently without needing the public electricity grid and relies on batteries to store the energy. But the on-grid system operates in parallel with the public electricity grid and does not require batteries as excess energy is sent back to the grid. What are the basic components of an off-grid solar power system? The basic component is the solar panel. Okay, number one, a charger controller to charge the voltage comes from the panel, batteries to store the power to use it later, and the inverter to convert from DC to AC, and the electrical load, of course. What is the function of charge controller in a solar power system? As I said now, the charger controller controls the amount of current and voltage going to the battery to prevent overcharging or over discharging. When the off-grid system gonna be best solution? The answer is in the places that are not connected to the electricity grid, such as farm, under construction site.